Good morning, everybody, and welcome to a quick video made by Mr. Tabarez today, providing a little bit of support on today's Subtracting Mixed Numbers quiz. Now, I've said this before, and I'll say it again. I do believe that subtracting mixed numbers, like doing 13 and 2/3 minus 1 and 5/8, or 4 and 1/3 minus 1 and 3/4, this is probably one of the trickiest, if not the trickiest, types of math that we learn in 5th grade. So if you're able to get a passing score on today's quiz, then you'll be able to get a passing score on any quiz that we throw at you later this year, okay? And so in order to make sure everybody feels as confident as possible, I wanted to grab a couple sample problems from the quiz today and show you how we can work them out with the LCD steps that we used before when adding and subtracting fractions, as well as this new technique called fraction borrowing that we showed you how to do this past week. So let's go and take a look and see how we could solve these two today. If you see these on your quiz, then you may be able to use them, all right? So let's start with that first one. 13 and 2/3 minus 1 and 5/8. First things first, remember that when we're subtracting mixed numbers, we always want to start by taking a look at the fraction parts first, okay? The whole number parts, the 13 and the 1, we'll look at those after. We look at the fractions first and see if we can subtract those. So to see if we can subtract the fractions, the first thing to look at here is to look at the denominators, everybody. There's a special rhyme I taught everyone when we were learning how to add fractions, although it also applies to subtracting fractions. So I'll swap out the word add with subtract and remind you that the rhyme goes like this. When subtracting fractions, first look on bottom. The same denominator, have both fractions got 'em? If yes, subtract your numerators, easy and free, but if not, you must next find an LCD. Remember that rhyme, folks, very handy. Because in this case, what that tells us is if we look at the denominators in our fractions first, we got this denominator 3 and this denominator 8. They are not the same, therefore we can't subtract these fractions yet. We must find an LCD of 3 and 8 first that we can convert both of these fractions into, okay? So let's go ahead and start with that. So 3 and 8, let's look over here at our times table chart, because that's always one of the handier ways to find a least common denominator. And if we look at our multiples of 3 and our multiples of 8, I can show you right there that our smallest multiple that 3 and 8 both multiply up to is 24. Therefore, 24 is going to be the LCD that we can use here, okay? So let's go ahead and put a 24 in that LCD box there. Pardon? 24. Let's get a 24 in this box, and I will get a 24 down here because our answer at the bottom is also going to have a denominator 24. So there we go, LCD is found. Next up, we now want to convert each of those fractions into a new equivalent form with that LCD of 24. So 2/3 we want to turn into an equivalent fraction over 24. The way we do that is by multiplying the bottom and top by the same number. So let's look at the bottom first. Our denominator right now is 3. We need to multiply it by something to turn it into 24. If you know your times tables, you know that that number is 8. Looking at the times table chart, 3 times 1 is 3, times 2 is 6, times 3 is 9, 12, 15, 18, 21, 24. 3 times 8 is 24. Therefore, let's get an 8 right there. 3 times 8 equals 24. Next, we know that whatever we multiply the bottom of a fraction by, we have to multiply the top by the same number to keep it equivalent. So we're going to do times 8 on the top as well. That means we're taking that old numerator 2 times 8, which, if you know your times tables again, that is 16. So let's go and get a 16 up here. And with that, we have converted our first fraction. 2/3 is now the equivalent fraction, 16/24. Next up, let's do the same down here with the 5/8. Same steps, we know the drill. Denominator first, 8 times what number equals 24? Well, we said up here that 3 times 8 is 24, and that's true if we just switch the two numbers around, right? So 8 times 3 is 24. If we did times 3 on bottom, we got to do times 3 on top. That is, we're doing that old numerator 5 times 3, which of course 5, 10, 15 is 15. So there we have it. 5/8 has now been converted into the equivalent 15/24. What that now means, everyone, is we got 16/24 now on top and 15/24 now on bottom. we got that common denominator now, so all we have to do is subtract those numerators, everyone. So now 16 minus 15. 16 minus 15, which I trust we know that's going to be 1. Now, for the fraction part in the answer, we got that done. It is 1/24. But don't forget, everybody, we're not just subtracting 2/3 minus 5/8. We're subtracting 13 2/3 minus 1 5/8. So that means the final step, and hopefully the easiest step, is to also remember to subtract your whole numbers, guys. So we're doing 13 minus 1 as well, which I trust we can work out as 12. And there we have it, everybody. 13 2/3 minus 1 5/8 ends up giving us a final answer of 12 1/24. 12 1/24. So as a quick refresher, we subtracted the fractions first, right guys? We did 2/3 minus 5/8. Had to find an LCD of 24. Had to convert the two fractions, 2/3 into 16/24, and then 5/8 into 15/24 with your multiplication. Then we were able to subtract the fraction part, 16/24 minus 15/24 was 1/24, and then made sure to subtract the whole numbers at the end, 13 minus 1, which is 12. And there we have it. So 12/24 is that first answer. At this point, we can now take a look at the second one over here. Now this one over here, everyone, is going to feature a couple more steps because we're going to have to do some fraction borrowing in this case. But still, we want to make sure that we are thorough in our steps, so let us go ahead and start from the top. So first of all, once again, when subtracting mixed numbers, the whole numbers we can look at later, we look at the fraction parts first, okay? So 1/3 minus 3/4. Let's see if we can do that part first. First of all, remember the rhyme, folks. When subtracting when subtracting fractions, first look on bottom. That is, look at the denominators. The two denominators have both, the same denominator have both fractions got them. In this case, we have a denominator 3 up here and a denominator 4 down here. So no, they are not the same. So remember the rhyme says, if yes, subtract your numerators easy and free, but if not, you must next find the LCD. So we'll need an LCD of 3 and 4, everybody, if we're going to work this one out. So let's look at that times table chart again. Here's our multiples of 3 one more time, but this time we're comparing it to multiples of 4. And if we look carefully, looking at multiples of 3 and 4, I can see the smallest multiple that 3 and 4 both share in this case is going to be 12. So that means 12 can serve as our LCD here. Thirds can become twelfths. Fourths can become twelfths. Our answer will have a denominator of 12 as well. Now we do have a couple other boxes up here labeled LCD, but I think we'll take a look at those a little bit later after we start the borrowing part. For now, let's just focus on the fraction part of things. So let's work out the same steps we worked out last time. Now that we got that LCD of 12, let's go ahead and now convert each fraction into new equivalent forms with that 12 denominator. So in the first fraction, 1/3, old denominator 3 times what number equals 12? I trust we can work out that that is 4. 3 times 4 is 12, which means we do times 4 on top. So now on the top we're doing 1 times 4, which I trust we can work out as 4. So 1/3 becomes the equivalent 4/12. Same deal down here. 3/4 is equal to how many twelfths? Denominators first. Old denominator times what number equals 12? Well, again, that is 3. We figured that out up here, right? So if we did times 3 on bottom, times 3 on the top, that means 3 times 3 on the top, which is 9. And there we have it. Our two fractions have been converted. 1/3 is now 4/12, and 3/4 is now 9/12. Now, here comes the next problem, everybody. If we would try to subtract these fractions now, remember we got 4/12 on the top and 9/12 on the bottom. So 4 minus 9, are we able to do that in order to get our numerator in the answer? Well, think of it this way. If we only have $4, can you buy a sandwich that costs $9? If you have only 4, can you take 9 away from it? Obviously no, folks, the answer is no. If the number on top is smaller than the number on bottom, you cannot subtract. There's another little rhyme I mentioned in class before, maybe you remember it. It goes like this. If there's more on top, no need to stop. But if there's more on the floor, you gotta go next door and borrow some more. So in this case, folks, we are going to have to do some borrowing here in order to create some more twelfths that we can add to the 4 twelfths we already have here to then to be able to subtract the 9 twelfths we have down here. So what can we borrow from in order to create some more twelfths? Well, remember, we have a whole number up here. This is 4 1/3, right? With 4 being the whole number. What we can do, everybody, is we can actually borrow one of those wholes, okay? Let's borrow one of those wholes, meaning we're going to cross out that 4, borrow 1 from it, meaning that 4 is now going to become a 3. As for that 1 that we're borrowing, you can see that I've moved it up here, and I'm now going to take that 1 whole, and I'm going to use it to create some more of the fraction piece we need, which, remember, our denominator that we're using is 12, right guys? That is, the fraction pieces that we're working with is twelfths. So you may recall that these 2 boxes we have up here are both labeled as LCD. After all, we need to turn that 1 whole into some twelfths today. And you may remember a special rule about wholes, everybody. 1 whole can always be turned into any fraction with the same numerator on top as the denominator on bottom. So some examples of that might be 1 whole could be equal to 2 halves. 1 whole is equal to 3/3. 1 whole is equal to 17 17ths. If you got the same number on top as on bottom, same numerator as denominator, you have a fraction equal to 1 whole. The same deal applies here. That 1 whole that we're borrowing can be converted or recut into 12 twelfths. 12 twelfths. That means that what we can do now, folks, is now that we have 12 twelfths up here, we can now add it to the 4 twelfths that we already have here. Add those together. So 12 twelfths plus 4 twelfths, 12 plus 4, 13, 14, 15, 16, right guys? 16. I beg your pardon. So let's go and cross out that 4 twelfths, and let's replace it now with a 16. Because we don't just have 4 twelfths anymore, we have 16 twelfths now. And so now, let's take a second look. 4 minus 9 was not possible. But we don't just have 4 twelfths anymore, now we have 16 twelfths. So now we can ask everybody, can we now do 16 twelfths minus 9 twelfths? And absolutely, now we can, everyone, right? Now we have more on top, meaning no need to stop, we can subtract. So 16 minus 9. Start with 16, take away 9. 15, 14, 13, 12, 11, 10, 9, 8, 7. 16 minus 9 is going to equal 7. So let's get a 7 down there in the answer. And remember, we're not quite finished. There's only one last very simple step. And that is to subtract the whole numbers now. Now remember, everybody, we originally had 4 minus 1 here. But remember, we had to borrow 1 from that 4, so that 4 became a 3. So we're not doing 4 minus 1 anymore. We're doing 3 minus 1. So 3 wholes minus 1 whole, that's probably the easiest part now. 3 minus 1 is 2. Which means we now have our final answer, everybody. 4 1/3 minus 1 3/4 is equal to 2 7 twelfths. So with that, my friends, there were 2 examples of problems you may see on your subtracting mixed numbers quiz. Remember to always check the fraction parts first. Make sure you have the same denominator. If not, find the LCD. Convert those fractions with your multiplication. Then make sure to subtract your whole numbers. If you find that after converting your fractions, the fraction on top is smaller than the fraction on bottom and you can't subtract, make sure to then follow your fraction borrowing steps like we showed you today. Alright? So with that, I trust you guys to do your best on your quiz today. Knock it out. I know you guys got this. Take care and we'll see you in the next one. Goodbye.